Good evening students, welcome to the class. Today we'll discuss first about enthalpy. Enthalpy means heat measurement, the amount of heat stored in a body, and it is designated with H. The change is designated as delta. So if we talk about the change in enthalpy, we have to write delta H. Delta H equal to delta U plus delta PV. Delta U means change in the internal energy. We have already discussed the internal energy in the last classes. So change in enthalpy is given by change in internal energy plus change in pressure and volume. When pressure is constant, we need to describe only the change in volume. So delta V. P is constant. This can be marked as equation 1. Now, when delta V equal to 0, the equation will become delta U plus P into 0. As a whole, this term will become 0 and we will be left with delta U. Now, you have to remember one formula where the enthalpy is equal to heat in a constant pressure, and delta U, which is internal energy, is equal to heat at constant volume, heat change at constant volume. So we have obtained delta H equal to delta U, and delta U is equivalent to QV. Q designating heat, and V is volume, constant volume. Next, we have to talk about exothermic reaction and endothermic reaction. Exothermic reactions are those reactions in which heat is released, heat is evolved. Delta H equal to minus, so the delta H term will become negative because heat is released in exothermic reaction, whereas endothermic reaction means absorption of heat. You need to apply heat in order that the reaction occurs. So endothermic reaction in which heat is absorbed or heat is required, in that case the heat of the system will increase, therefore it is positive. The change is positive. Here the change will be negative. Now, extensive property of a system. What do you mean by extensive property? The property of a system which depends on the mass or the amount of matter present, that is the extensive property. For example, volume. Volume, what is the volume formula? You know that density is equal to mass by volume, right? So volume is equal to mass by density. So this is the formula, and you know that volume is dependent on mass. In order to take out the value of for volume, you have to determine the mass. So this volume is dependent on the amount of substance present in the system, therefore it is a extensive property. Similarly, intensive property is another property of a system which does not depend on the amount of substance present, the temperature, density and pressure. So these are the examples of intensive property. So when we talk about 1 kg of iron and 2 kg of iron, and we are going to heat it at the same temperature, and after 5 minutes you will observe that the temperature of both the pieces of iron are similar. One was 1 kg, the other was 2 kg, so that does not make any difference in the temperature. It means temperature is independent of the amount of substance present. So that is the intensive property. Next, we will talk about the standard enthalpy of reactions. Standard enthalpy of reactions. For that, we have to know what do you mean by standard state. First, we have to go through standard state, then we can define the standard enthalpy of reactions. So what is the standard state? The standard state actually is different for all substances. 2 examples I have taken here. Ethanol. When ethanol will be said to be in the standard state, when the temperature will be 298 Kelvin and the pressure is 1 bar, then ethanol is obtained in the pure form. It is a pure liquid. That state of ethanol is known as the standard state. For iron again is different. 500 Kelvin is the temperature where you will get this standard state of iron. provided that the pressure is always maintained at 1 bar. So the pressure is always 1 bar, but the temperature will change, and at a particular temperature you will get a particular standard state of a substance. So this will be different for every other substance. So this is the definition for standard state. Clear? Now we can define the standard enthalpy of reactions. If you have the book, you can see that the definition is given as the enthalpy change for a reaction when all the participating substances are in their standard states. Suppose there is a reaction where A plus B and C plus D. So in this reaction, the participants are A, B, C and D. And if I am maintaining the standard states of every participating elements here, that is A, B, C and D, then that enthalpy change occurring is called as standard enthalpy of the whole reaction. Is it clear? When the participating elements or compounds are in the standard states, then only we can define that the enthalpy change occurring here, either enthalpy will increase or enthalpy will decrease, isn't it? So that change will be standard when the participating elements are in their standard state. And what is the standard state? The standard state of a substance at a specific temperature, you see, at a specific temperature. Why? Because for every element this temperature will be different, right? So for every specific temperature in its pure form, when the standard state of a substance at a specified temperature is its pure form, it has to be pure. At this particular temperature, the standard state of a substance is pure, provided that the pressure is maintained at 1 bar. So this is the definition for standard state and the standard enthalpy of reactions. Now we will get enthalpy changes during phase transformation. So how does the enthalpy change when phase transformation means, phase means state, solid, liquid, gas. Transformation means from solid to liquid, liquid to gas, then solid to gas. All these are transformations of the different states, right? So first one is from solid to liquid. Whenever any reaction occurs in which the solid is converted to liquid, for example ice is converted to water, so that is known as what? Melting, right? So this is known as also fusion. Now when we say enthalpy change that accompanies melting of 1 mole of a solid substance in standard state, is called standard enthalpy of fusion. We are talking about standard enthalpy, so the name will be standard enthalpy of fusion, which is designated as delta FUS H naught. Okay, so enthalpy of fusion, standard enthalpy of fusion, this is the designation. And how it is defined? The enthalpy change that accompanies 1 mole of a solid substance converted to the liquid in standard state. So in the reaction, all these solid, whatever solid and whatever liquid is from, these two has to be in the standard states. Clear? And whatever solid that it will take, it has to be 1 molar. Clear? And when we convert, for example, ice to water, solid to liquid, ice to water, in that ice to water transformation 6 kilojoule per mole is required. Means for every mole of ice it will require 6 kilojoule of heat. Okay, then only it will convert, then only the solid can be converted to liquid. that much amount of heat is required. 6 kilojoule of heat is required so that solid, 1 mole solid gets converted to liquid. So this is your enthalpy of fusion, standard enthalpy of fusion. Clear? Standard enthalpy of fusion or molar enthalpy fusion. So you can write in full form. Okay, so there is no space here, so I have written in short form, otherwise I have been saying these words. So this is standard enthalpy of fusion and this is molar enthalpy of fusion. You can say anyways here. Next you will get from liquid to gas. This is vaporization, right? From a liquid you will heat and it will be transformed into gas. So liquid to gas is vaporization, and we will say standard enthalpy of vaporization or molar enthalpy of vaporization. The same thing is repeated here. 1 mole of the liquid is taken, 1 mole water is taken, and you have to apply 40.79 kilojoule of heat. Then 1 mole of the water will be converted to the steam. So this is standard enthalpy of vaporization, and it is designated as delta VAP H naught. So this is the designation. Clear? Next, the last one is your solid to gas. Whenever solid converts itself directly to gas without being transformed into liquid, usually what happens, a solid will be converted to liquid and the liquid will be getting converted to gas, right? But sometimes some solids like naphthalene, so these solids will get converted directly to gas. They will not undergo the liquid transformation. So this procedure or this process is called sublimation, and we will talk about standard enthalpy of sublimation. It does not have any other name, okay? So standard enthalpy of sublimation. Then 1 mole of the solid you will take and it will be converted to gas. In case of carbon dioxide, in case of dry ice, the amount of heat required is 73 kilojoule. So you have to apply 73 kilojoule, then only it will convert itself to gas. So these are the things here. It's enthalpy, remember, it's enthalpy means heat measurement or the content of heat that is present in the system. So heat, whenever we talk about a reaction, whether heat is produced, okay, so that produced heat means it is released, that process is known as exothermic. But whenever you have to apply heat in order that the reaction occurs, that is known as endothermic reaction, that is heat is absorbed, they will use up the heat. Clear? The last topic that we are going to discuss is the standard enthalpy of formation. The definition is the standard enthalpy change for the formation of 1 mole of a compound from its elements in their most stable states of aggregation is called standard molar enthalpy. It means formation of, the definition might seem very difficult, but actually what is trying to say, you have to form 1 mole of a compound, okay, and you know that formation of a compound will require some reactants, require some elements, suppose A, B and C. Then this A, B, C element has to be in the stable states. Now only the point is that we have to know what do you mean by stable states. Okay, stable state is also referred to as the reference state. What is the meaning of reference state? When the element is stable. Stable means they do not have any tendency to react, they are in the molecular state. When we talk about oxygen, the standard state will be, the reference state will be O2, because O2, this is a molecule, it will not it is in the stable state, okay, it is satisfied, the orbitals of the oxygen is satisfied, the configuration is full. So this is the reference state for oxygen. Similarly for hydrogen, it's H2. Next, the temperature should be maintained at 25 degrees Celsius, which is the standard temperature, and pressure you now already know, it's 1 bar. Okay, so reference state means the state of the element where it is stable, it is 25 degrees Celsius, the temperature, and pressure is 1 bar. So that is the reference state. So whenever any reaction is occurring, 1 mole of the compound is formed from the reference states, then that is known as the standard enthalpy of formation. For example, you take this reaction, water is a compound, H2O. What are the elements here? Hydrogen and oxygen. What is the reference state for hydrogen? Each H2, okay, it's H2. Then for oxygen, it's O2, right? So H2 plus O2 H2O, right? So but if you try to see here, this is here 2 oxygen and here oxygen. So now since we are talking about the standard enthalpy of formation, we cannot take O. Oxygen does not remain as in its atomic state, okay? You will never get O here. It will directly react with some other compound. This element is known as the nascent oxygen, okay? So this entity, not element, sorry, this entity is called the nascent oxygen, and it is very reactive. It will directly react with some other compound or other element, okay? Now here you see we have to take a half, okay? Half of O2 means signifies O only, but we cannot directly take O, so we will take half of O2, then you will get H2O. So this is the example of standard enthalpy of formation. And here how much and what is the change in enthalpy? Minus 285.8 kilojoule per mole. Okay, why it is minus here? Why the enthalpy has been negative here? Because in simple terms, if you see gas, gas to liquid and liquid to gas, whenever we talk about liquid converting to gas, we have to apply heat, right? We are applying heat. It means what? We are providing the heat, means the heat will become positive, right? You have to add the heat. Whatever heat the liquid is having, you have to add extra heat so that the liquid gets converted to gas. But now we are talking the opposite. From liquid you have to convert from gas you have to convert to liquid. Now what is happening? Backward, na? From gas some amount of heat you have to release. Some amount of heat is released, then only it will cool down and form the liquid. Clear? That is why it is negative here, because H2 is gas, O2 is gas, and this is water, liquid. So here negative enthalpy is observed. Now again you see another example, C2H5OH. So this is ethanol. This is the example for ethanol, and the elements present is carbon, hydrogen, oxygen, and again hydrogen, okay? So what are the elements present? That is carbon, hydrogen, and oxygen. What is the reference state for carbon? It's carbon only, okay? Graphite. Then for hydrogen, you know, it's H2. For oxygen, it's O2. Now you have to put the coefficients in such a way that the elements, the number of elements present in your left hand side becomes equal to the right hand side. You have to balance the reaction. Clear? So how many hydrogen is there? 5 plus 1, total 6 hydrogen. So you can put a 3 here. So 3 into 2, 6 hydrogen total. Clear? Means what? H2, 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 because 3 H2 na, H2, 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 1, 2, 3, 4, 5, 6, total 6 hydrogen. Then O2 I have already told why you cannot put just simple O, you have to put half of O2, and half of O2 means O only, okay? So O, so you have got here O. So this is also an example of negative enthalpy change. It is minus 77.7 kilojoule per mole. Clear? So now you will get some examples which from where you will know that these examples are wrong examples for the standard enthalpy of formation. Let us see how it is wrong here, because you have to know the opposite thing also. Calcium carbonate, okay? In calcium carbonate, what are the elements? Calcium, carbon, and oxygen. What is the but now you see here in your left hand side, you see calcium oxide. This is a compound, no? This is totally a compound. Again carbon dioxide, again this is a compound. So these are not the elementary states. It has to be in the elements 1 1 1, okay, individually. But here it is in the combined form. It is a compound. This is also a compound. So you cannot say that this is an example of standard enthalpy of formation. Clear? Next again you see here H2 plus Br2 HBr. What are the elements? Hydrogen and bromine, H and Br. But if you see here, this is okay, right? Because for hydrogen it's H2, for Br it's Br2. They are not in compound form. They are not combining with any other element. They are combining with itself only. So what is wrong here? Recall that I have said when 1 mole of the compound is formed, but here you see 2 mole of the compound is formed now. So this is also not example of molar enthalpy of formation. But we can change this one. How? If you divide by 2 in both the sides, what you will get? Here if you divide by 2, here 1 by 2, here 1 by 2, 1 by 2, 1 by 2, and here it will become now 1. So 1 mole, right? 1 mole of the compound is from. So now this is the correct example for molar enthalpy of formation. Is it clear? Standard enthalpy of formation.